Algebra, Chapter 6, Section 2, Solving Systems by Substitution. In the previous video, we solved by graphing. In this one, we will use substitution to solve our linear equations. What is substitution? Well, a substitution is something taking the place for something else. And we use substitution in our everyday language. As an adjective, we have a blank teacher in social studies class today. We have a substitute teacher. As a noun, the coach made a substitution of one player for another. So substitution is substitute used as a noun. As a verb, to evaluate the expression x plus 6, you can substitute a number for x. Write a combination of coins that you could substitute for each dollar amount. Now, of course, these could vary quite a bit, but remember to use coins. So pennies, nickels, dimes, and quarters, and half dollars if you really want to use them. In the last video, you learned how to solve systems of equations by graphing. In this video, we will talk about using the substitution method. To use a substitution method, you solve one of the equations for one of the variables. So you isolate one of the variables. Then substitute the expression for the isolated variable into the other equation. Let's go see how this is done. Here are the steps for solving by substitution. Step 1, solve an equation for either x or y. Step 2, substitute this into the other equation and solve for the remaining variable. Step 3, substitute this number into an equation to find the missing variable. Again, I realize that can be kind of confusing, so let's work through a couple problems. Here we have a system of equations. In both equations are in slope-intercept form, so the y is already isolated. So I can take this value and substitute in place of the y in the second equation, which makes 2x plus 7 equal to x minus 1. Since I now have 2x plus 7 equals x minus 1, I can put the x's all on one side, put the constants on the other side, so x is equal to negative 8. Now that I know that x is equal to negative 8, I can put it back into either equation, either one of the original equations, to find the value. I'm going to pick the second one just because it seems to be a little bit easier. I'm going to put negative 8 in where the x is and solve for y. Whoops, you see my error? So y is going to be equal to negative 9. So my solution is negative 8, negative 9. Now once again, I need to check my answer. And I need to do it in both cases. And as you can see, the first case is true. Check the second case. And of course, the second case is true as well. As I said in the graphing video, graphing is a great way to solve systems of equations when the systems cross where the x and y values are integers. But it's a difficult way of solving equations when they're not. And we're going to see that in this case, substitution would be an easier way of solving. So first step, looking at these two equations, we're going to solve one of them where we get a variable isolated. So the easiest one to do that is the second one where x is already isolated. So we're going to subtract 3y from both sides. And we'll get x equals negative 7 minus 3y. Now I'm going to take this value, this minus 7 minus 3y, and put it in place of the x in the other equation. Here's our other equation in our system. Notice the x is by the 5, so I'm going to put minus 7 minus 3y. Now notice I've used parentheses to do this. Remember when I used to tell you over and over, whenever you're replacing a variable with a value, use parentheses. Well, this is why, because we actually need to distribute that 5y through. So we get 5 times negative 7 is negative 35. 5 times negative 3y is negative 15y. Put our y's together. So that's 9y minus 35 equals 8. When we add 35 to both sides, we get 9y equals 8 plus 35. 8 plus 35 is 43. Now divide both sides by 9, and we get y equals about 4.8. Now I'm going to take my negative 4.8 and put it in place of the y in the next equation, putting this in place of the y. So this becomes x minus 3 times 8 is 24, carry the 2, 3 times 4 is 12, 13, 14. So 14.4, add that to both sides. So x is about 7.4. So my solution is about 7.4 and negative 4.8. Now if we had graphed that, finding where those two lines cross would be extremely difficult. But using substitution, it wasn't too bad. If you feel comfortable solving the system of equations by substitution, I want you to go ahead and try it. If not, follow along with me. Looking at the system, I see I have a y here that has a coefficient of 1. So I'm going to isolate that y. Add 6x to both sides. So that y is going to equal 6x minus 7. Now it's important for you to realize that this equation and this equation are exactly the same thing, just in a different format. So using this equation, I can take this 6x minus 7 and substitute it in for the y in the top equation, in the so far unused equation. So I'll have 3 times 6x minus 7 plus 2x equals 4. All I did was substitute that 6x minus 7 in for where the y was. I'm going to go ahead and distribute and simplify and solve. And as you see, my x equals 5/4. Now I'm going to take this 5/4 and I'm going to put it in for the second equation. Now I can use either this version or this version because it's the same equation, just a different version. I'm going to use the slope-intercept form just because it is a bit easier. Notice I'm using my parentheses to keep myself organized when I replace a variable. So y equals, I cancel. I got 15 halves minus 7. 15 halves minus 7 is 1/2. So I believe my solution is 5/4 and 1/7. And the reason I say I believe is because I need to check it. And so I'm going to go ahead and do that. As you can see here, I've rewritten my equations, but I have left my places blank. So my y value of 1/2 is going to go into my y values. My x value of 5/4 is going to substitute in for my x's. So 3 halves plus cancel, 5 halves. Does it equal 4? Well, 8 halves does equal 4. So it's true for this equation. Here I do my canceling. So I have negative 15 halves plus 1/2. Does that equal negative 7? Well, of course that equals negative 14 halves, which does in fact equal negative 7. So it is true for my second equation. So this is the solution to the system of equations. Most of the time when you solve systems of equations, you will get a x equals a value or y equals a value, some sort of a variable equals a value. But occasionally you won't, you'll get something different. One of the different things you may get is something like 2 equals 2. Or the left side has a real number which is equal to the same real number on the right side. If that happens, you get what's called an identity. An identity means it has infinitely many solutions. The other option that you may get if you don't get a variable equals a real number is something like 8 equals 2, where the left side and the right side are obviously not equal. In that case, it's considered a false statement, and that system has no solutions. How that information looks like in a problem. In this system, the first equation is already in slope-intercept form. It already has the y isolated. So I'm going to use that information in my second equation. So instead of y, I'm going to put in x plus 3. So I put this in place of where y used to be. Minus x plus x is 0, so I get 3 equals 4. Now obviously 3 equals 4 is not a true statement, so it's a false statement. And what do you remember about the previous slide? Yes, a false statement means there is no solutions. Here's another example. Again, we're going to substitute this in for the y. So you get minus x plus 2 times 1/2 x plus 1 equals 2. This came here. I distribute, so negative x plus 2 times 1/2 x plus 2 times 1 equals 2. So negative x plus 2 equals 2. These cancel, so 2 equals 2. That is a true statement. It's called an identity. An identity means that it's multiple solutions, so it's going to be all real numbers. That's a symbol for real numbers. All real numbers means it's the same line. This is where you can check your own understanding and mark your math success. I'll see you in class tomorrow.